Okay. And I can explain what this means and try to visualize what this means in a minute here. Okay. A revolution is basically just a full circle, right? A revolution. And you don't have to draw this picture. You really don't have to draw anything on the next couple slides, but just explain like what a volume of a revolution is. Let's say you have a line, okay? Let's say that line is y equals x, okay? And this is just a line on like an XY axis, and let's put it in three-dimensional plane. If I were to take that line, right, think of it like a lever, like I'm grabbing it, and just revolve it around an axis, that's going to give me like a circular shape, right? That's going to give me a solid. It's going to give me something that I can take the volume of. So when we say volumes of revolutions, we're taking a graph and we're pulling it and basically revolving around an axis, and then we can cut through that and see what the volume is. You don't have to write this down because you're going to see this on the next couple examples. There are two methods to finding volumes with revolution. One is the disk method, one is the washer method. And it just, disk and washer just resembles like what the shape is. So let's take this blue shape, right? Let's say I have a graph right here, and let's say this is my original graph. If I revolve that around the x-axis, it's going to give me some sort of disk shape anywhere I cut through that, right? Here's a disk right here, a solid disk. Anywhere I cut through that, it's going to give me a solid disk. Here's another one. If I take this graph, revolve it around the x-axis, and cut through it, it would give me this disk, right? It's like looking through it. A washer, if anyone wants to think of like lifesavers, or I don't know if you work with tools or repairing stuff and things, like washers are used to tighten things. It's got a little gap in the middle because you have two curves. And when you revolve those two curves around, you basically you have a gap in the middle, like a lifesaver, CDU, however you want to picture it. So two methods: washers, discs. We'll try a couple of each one. Okay. There are formulas for each of these. So let's start with disk. This is the one this is the part I think you want to start getting in your notes. So I'll give you what disk means or what it is, and then I'll give you a formula. Here's kind of the big one. Formulas underneath that. So revolving around the x-axis and revolving around the y-axis. This would be y-axis revolution. This would be x-axis revolution. Right. Again, don't necessarily have to draw this, but revolving around the x-axis looks like this. Revolving around the y-axis would look like this, okay? Maybe you guys picked up on this already, but really, you're just taking the area of this circle times the depth. So if you look at this, pi r squared times your depth. Pi r squared times your depth. So it's really just area of a circle, pi r squared, and then multiply it by dy or dx. Okay, that'll give you your volume. All right, if you're ready, we'll flip ahead and do a couple of these. All right. Oh yeah, forgot. We got to do washers. This is the formula for washers. This is if you have multiple curves. Yeah, so multiple curves kind of looks like that. Okay, I got a lot of questions in my last class on how do you know when to use disk and when to use washer once we started doing examples. If your axis of revolution is separate from your two curves, right? You have two curves that are separated from your axis of revolution, then you have to use washer, okay? Because basically you're finding the area between these two curves and then revolving it. So washer is when you have two curves separate from your axis. Disk is when you just have one curve connected to your axis. Okay, I'm going to jump ahead. And let's do this one. So again, you don't have to write these hints down, probably just the boundaries, and then we're revolving around the x-axis. All right. Again, always helps to graph this just to see what you're looking at. Boundaries are y equals square root of x, so that looks like this. Y equals 0 is the x-axis, and x equals 4 is right here, x equals 4. And this is y equals square root of x. Okay. And now this says we're revolving about the x-axis. So we're going to take this shape and we're going to take it and we're going to spin it around this x-axis to create basically like a circular disc or cup, whatever you want to call it. Notice though that we have one axis of rotation and we have one curve. Okay, so we are not going to be using washer. It's just one solid disc when you rotate it all the way around. Okay, so another thing is we're not rotating it about the y-axis. We're rotating it about the x-axis. So we're going to use that first formula. Okay. Now we know what pi is. We just have to find our radius and our boundaries. We can plug it into our formula. Our radius is just the distance from the axis of rotation to the outside, which is square root of x, right? So I would write volume is equal to pi. And what are our boundaries or our parameters? We're going from 0 to 4. right? This would be 0 to 4. What's our radius? It would be square root of x squared dx. And again, just notice this is pi r squared. It's the area of a circle times the depth. That'll give you volume. So if you go plug that in, hopefully we'll all get the same answer. Should be getting 25.133. See if we can get that. All right. So that's like a basic disk problem. Solid disk. All right, let's try a washer. Okay, so we'll do boundaries are e to the x, e to the second, and x equals 0. And we're going to revolve it around the x-axis. Actually, I'll do two washers with you because these are kind of, some of these can be tricky. All right. So let's graph it. We've got e to the x. Let's graph that first. That would look like this. Like this. That would be e to the x. E to the second is just a constant. Y equals e to the second. If you plug that in your calculator, it's just going to be a constant straight across. And x equals 0 is our third boundary. So that's the y-axis. So basically, it's telling us like this region in here is what we're revolving. And now we just have to be careful. We're revolving about the x-axis. So we're taking this and we're spinning it about the x-axis. Okay. This is a washer because you have your axis of rotation and you have two separate curves above it. So you know it's a washer method instead of a disk method. Okay. So let's cross out. We're not using this. We're not using this. We're going to use washer. Okay. Washer method is just subtracting the larger radius squared minus the smaller radius squared. Okay. So let's write what our big R and our little r would be. Large radius would be basically from the axis of rotation to the top curve. All right, that large r would just be e to the second. Okay, little r would be from the axis of rotation to the bottom curve, which is e to the x. And from there, it's actually, what are we missing? What do I still need? I can't just plug it in. The boundaries, right? So I know my one boundary is 0 because it says x equals 0. How do I find, do this in a different color. How do I find this value, that boundary right there? What do you think? Exactly. Set your two functions equal to each other and see where they intersect. And actually an easier way to do that would just be to go to your calculator and do like the intersection tool, where you go to like second calc and it will give you this intersection. Your x value right there is actually, what is it? What do I have here? 2. Okay, so those are your boundaries, 0 to 2. And you can do, just like Ilya said, set them equal to each other and solve, or you could just use your calculator and find your intersection point. This is going to be from 0 to 2. E to the second squared minus e to the x squared dx. I don't want to have trouble with parentheses, so I might simplify it a little bit more before I put it in my calculator. And I would just write it like this, right in my calculator. Okay, give that a try. See if you can get, what did I get here? 258.859. So that's another thing you're going to need to know for the quiz is how to find intersection points between two graphs. Make sure you know on your calculator, second calc is how you find the intersection tool. All right. If you can't find that, let me know. I can show you where it is. Okay. All right. Let's do, we're winding down. I promise, guys, we're almost there. Let's do, I have one more washer that's like the most complicated type, and then I'll do one where we're just revolving around the y-axis, and then we'll be done, okay? Those of you at home, I feel for you because I know this is a long day of notes, and it's never easy to just sit there on the other end and write all this down. Okay, so let's do this one. Now we're revolving around a line y = 4. We're not revolving it around an axis, about an x or y axis. All right, let me plot these really quick while you guys are writing this down. So we have x squared and we have 4x minus x squared. So this is x squared. This is 4x minus x squared. Okay, and we're revolving around the line y = 4. So that's, it's up here somewhere. That's our axis of revolution now. What do you guys think? Disk or washer? Throw a guess out there. Disk or washer? Washer, yep. We have an axis of revolution, and then we have two separate curves outside of that. So we're going to use, washer method, which is that bottom. Okay, we just need, all we need is our two radius points. And actually, we would also need to know our boundaries too. Well, let's worry about our radius right now. We're going to do big R, which is basically the furthest point, right, from your axis of revolution to your bottom curve. Let's call that big R. And then we would need a little r. This is going to get really messy, but I'm squeezing it in here. Would be like from your axis of revolution to your closest curve. Okay, so that would be little r. Okay. Okay. So to get this distance, you would say basically you want to subtract. You'd want to say 4 minus whatever that value is. So your big R would be 4 minus x squared. Okay, 4 minus x squared would give me this distance right here, that big R. Now little r would be 4 minus, now I'd have to subtract out this. So this would be 4x minus x squared. That would give me that distance for little r. And actually, let's simplify this more. This would be 4 minus 4x plus x squared. Okay, so we're almost there. I'm going to say volume is equal to pi. Now we need our boundaries, right? So you would have to go on your calculator and see where these two meet each other. There'd be one right there and there'd be one right there. Again, just to save you guys some time, go second calc intersection, find where they intersect. It would be at 0 and it would be at 2. Those would be the 2 points of intersection. Because then that would give us this region right here. All right, and then you just subtract your, so I'm going to say 4 minus x squared minus 4 minus 4x plus x squared dx, and that's exactly what you'd put in your calculator. Nate, did you have a question? Yes, good catch. Thank you. It should be squared. Yep, my bad. Yeah, those radius should be squared, r squared. Should get 33.510 units cubed. All right, I think we're ready for our last one. I know, again, I know like we had a lot today, but at least you'll have it for your open note quiz. You'll have all different types. So let's just do one. So you just have this as an example, at least in your notes. One where we're revolving around the y-axis. We haven't done one like this yet. This will be our last one. Okay, I'm gonna plot this while you guys are writing down. 1/4 x squared, something like this. X equals 0, x equals 2. So we're bounded by x equals 0. So that's the y-axis. And x equals 2. Okay, this, you have to be careful here. It says bounded by the y-axis and this function. So it's not this area right here. It's actually this area right here, because it says bounded by the y-axis, not bounded by the x-axis. Okay. The reason I have the 2 here is just because it says from x equals 0 to x equals 2. So I know from 0 to 2. Okay. So we're taking this and we're revolving it around the y-axis. It's not going to be a washer. It's not about the x-axis. It's actually going to be this one, revolving around the y-axis. So, okay. But to do that, though, we have to write our radius in terms of y, just like we did for cross sections. We have to flip the function. So my radius is going to be, so my original was 1/4 x squared. My radius then would be x is equal to square root of 4y. Now, this would just be positive because we're only looking at half of it, this half of it, okay? So that's your radius. You can, at this point, you can just start plugging into the formula. So we have volume equals pi. All right, here comes trouble. Where's our boundaries? Is it 0 to 2? No, what do I do for my boundaries? 0 to, someone said it, I thought. No. How do I get, so now remember my y-axis, I'm going in this direction. How do I get that top boundary? What do you guys think? Any ideas? What if I took 2 and plugged it in the original function? That would give me my y right there, right? If I took this, plugged it in, that would give me that top boundary. Right, so 2 squared is 4 over 4 is 1. So actually this is 1 right here. So we're going from 0 to 1. And after that, it's just plugging in. So this is going to be square root of 4y squared dy. And you get 6.283